and welcome back to another Science with Ms. Dubois video. In today's video, we are going to talk about pure substances and mixtures. That's me, Ms. Dubois, so let's begin. Here we have this concept map, and I will be adding on to this concept map throughout the duration of the video. So the concept map starts off with matter, and matter is anything that has mass and takes up space. And all matter can be split up into two main categories: pure substances or mixtures. Right now, we are going to focus on the pure substances piece. You might be asking, what is a pure substance? A pure substance is something that is made up of one kind of particle that has a fixed or constant structure. It cannot be taken apart without changing the properties of the substance into something else. And examples of this include gold, water, salt, sugar, and so many more things. There are two main types of pure substances: elements/atoms and compounds/molecules. So now that we have this tad bit of more information, let's add that onto our concept map. Here we go. Now, as you might notice, I actually split up molecules and compounds, and that is because molecules and compounds are different enough where they can each have like their own sort of category, but essentially they are kind of the same thing. And I'm going to explain that further on in the video. But right now, I'm going to focus on the elements/atoms. What is an element? An element is something that is made up of one type or kind of atom. And all elements can be found on the periodic table. But you might be asking, what is an atom? An atom is the smallest unit of matter. It is the building blocks of all matter. And examples of atoms include gold, aluminum, neon, and so many more things. So let's dive into this idea of atoms being the building blocks of matter a little bit further. Atoms are very similar to Legos. A singular Lego is a building block, and when multiple Legos are combined and added together, they can turn into these elaborate creations, all because they started with a singular Lego. So Legos can be built into these massive houses or these elaborate creations, or even this duck, and so many more, right? All because of a singular Lego, right? And multiple Legos added onto each other to make these incredible creations. Now, all of these things are totally different than each other and totally serve different functions and purposes. That's very similar to atoms. When they're bonded to things like molecules and compounds, they will have different functions and different purposes and behave and act totally differently. Now we know a little bit about elements/atoms, right? We have our examples and so forth. Now let's focus on the molecules piece, right? You might be asking, what is a molecule? A molecule is when two or more atoms are bonded together. They can be the same type of atom or different types of atoms. We can see this with water, salt, O2, oxygen gas basically, and sugar, and there's so many more. Water is a molecule because, as you can see here, there are 1, 2, 3 atoms bonded together. That makes it a molecule. Salt is a molecule because you can see that there's 1, 2 atoms bonded together, making it a molecule. Oxygen is a molecule because you can see 1, 2 atoms bonded together. In water particularly, you see 2 different colors, right? Same with salt, 2 different colors. Those are 2 different types of atoms bonded together. But in oxygen, you see the same atom bonded together. That is true for molecules. And we can also see this in sugar, right? Sugar is C12H22O11. This is commonly known as table sugar. Basically, this is a fancy way of showing the chemical formula that makes up the sugar that we all eat most likely. And these are all different atoms bonded together. I didn't draw it out because it's a really complex structure, but you get the idea. These are different types of atoms bonded together. Now that we know a little bit more about molecules, let's add it onto our concept map. Let's focus on compounds now. A compound is when 2 or more different types of atoms are bonded together. We can see this with water, salt, and sugar. We're seeing a little bit of a similarity here, right? So let's add this onto our compounds thing, right? When 2 or more different atoms are bonded together, and we have our water, sugar, and thing. But as you can see here, I kind of tweaked the concept map from earlier, right? And I made it a little bit more accurate. As you can see, water, sugar, and salt are also connected to molecules, right? Because they have 2 or more atoms bonded together. And that is because all compounds are actually considered to be molecules. So you might be asking, what is the relationship between molecules and compounds? Well, all compounds are molecules, but not all molecules are compounds. But why? A very reasonable question, and a question that I've even asked myself when I was learning about this type of stuff. Molecules just require 2 or more atoms bonded together. Compounds always meet that requirement by having 2 or more different types of atoms bonded together. Some molecules only have the same type of atom bonded together. In that case, it's not a compound because it doesn't have 2 different types of atoms bonded together. That's why I put molecules in its own kind of category, right? So let's look at water again, right? We have 1, 2 different colors, right? That makes it a molecule because it has 1, 2, 3 atoms bonded together. And it also makes it a compound because it has 1, 2 different types of atoms bonded together. We can see this with salt because yes, there's 1, 2 atoms bonded together, making it a molecule, but there's also 1, 2 different colors, therefore different types of atoms bonded together, making it a compound. And with sugar, the capital letters, if you know anything about chemical formulas, and if you don't, that's totally okay. I have a whole video on it on my YouTube channel that will be linked below. These all represent different types of atoms, and they're all bonded together. There's more than 2 of them, making it a molecule and a compound, right? Because more than 2 atoms bonded together make a molecule. More than 2 different types of atoms make it a compound. On mixtures, right? You might be asking, what is a mixture? A mixture is something that has 2 or more pure substances, and it can be taken apart or separated through physical means. Examples of mixtures include coffee with milk, salads, Kool-Aid, and bags of Jolly Ranchers. And there are 2 main types of mixtures: homogeneous mixtures and heterogeneous mixtures. So now that we have a little bit more information on mixtures, let's add that to our concept map. Let's focus on the homogeneous mixtures. What is a homogeneous mixture? It's a mixture that looks the same throughout. Examples include coffee with milk, Kool-Aid, brass instruments, right? You cannot tell the difference between these things, like in the individual mixtures, right? Because they look the same throughout. But all of these are actually mixed with a bunch of stuff that can be physically separated or separated through physical means. They all look uniform, the same throughout, so that makes it a homogeneous mixture. We've added the homogeneous mixtures piece to our concept map. Now, let's finish off with the heterogeneous piece to our concept map. A heterogeneous mixture is a mixture that looks different throughout. And we can see this with salads, a bag of Jolly Ranchers, or bags of candy in general, salad dressing, right? All of these, you can clearly pick apart what makes it different. And it does not look the same throughout. It looks different, right? So now that we know a little bit more about heterogeneous mixtures, let's add that to our concept map. And that's the video. I'm Science with Miss Dubois. I hope you enjoyed this video.